Okay. Good evening, everyone. Continuation of yesterday's objective. I am going to share the next problem on the screen. Observe. The domain of the function root of 2x minus 3 plus sin x plus root of x minus 1. Root of 2x minus 3 plus sin x plus root of x minus 1. I am going to do this problem in the normal method. After completion of normal method, let me discuss the shortcut. Okay. See the 23rd problem on the screen. Stop sharing. Yes, see here. Normal method. This is in the form of root of f of x or f of x plus g of x plus h of x. So you should find out the domains separately and you should write the intersection of those three domains, right? So further say, see root of 2x minus 3 domain separately means 2x minus 3 is greater than or equal to 0. This is in the form of root f of x means f of x is greater than or equal to 0. X is greater than or equal to 3 by 2 means the domain of this function becomes 3 by 2 comma infinity open interval. Now the domain of sin x is capital R, right? The domain of root of x minus 1 means x minus 1 is greater than 0 or equal to 0. X is greater than or equal to 1. That means this is 3 by 2 means 1.5. See the domain by taking this real numbers, that is real plane 0, okay, 1, 1.5 and this is infinite. Okay. Now the domain of this one becomes 1.5 to infinite. The domain of this is R means total. And the domain of this one becomes 1 to infinite. So what is the intersection area? This one means the domain of this function is 3 by 2 comma infinite in open interval and this is 3 by 2 closed interval. Copy this one. This is the normal method. Now I think the same problem is there in front of you, that is 23rd problem. Observe the options given to you. See, observe the options given to you. First option minus infinite comma 1. Second option 0 comma 1. Third option 3 by 2 comma infinite. So see how to do this problem through verification method. Through option verification means you just pick up one option called minus infinite to 1. Okay. First option, listen, minus infinite comma 1. This is closed, this is open. How to do this problem through verification method? Now just substitute 0, right, in the problem. It becomes 0 minus 1 under root. It becomes negative. That means this entire function does not exist. Hence this option is wrong. Second option given to you, it is 0 comma 1 in closed interval. 0 comma 1 in closed interval. Here he has given you 0 in closed interval means it is included. Hence if you substitute 0, the same problem occurs. That's why by seeing the problem itself, you should judge at least 2 options. After judging of 2 options, right, you should go through the 100% accuracy of remaining 2. Now the third, this is also wrong. Third one, it is 3 by 2 comma infinite. So this option is right according to our normal method also. Copy this one, copy both methods. So let us do the problems by using shortcut methods. Why? Because time is less. Yes, copy that one. See that problem number 24 on the screen. See that problem number 24 on the screen. The domain of cube root of x into cot x. Cube root of x into cot x given to you. I hope you are observing that one. See here, f of x is equal to cube root of x into cot x. Right? This is defined for all values of positive real numbers. This is defined for all positive real numbers. Right? Now, if you observe this one carefully, cot x can be written as, you just substitute as it is, cos x by sin x. This function is defined if and only if sin x should not be equals to 0. Means x should not be equals to n pi. So you just observe the option r minus n pi will be that. See, I think the answer should be third option, r minus x such that x is equals to n pi. You can also write that one as r minus n pi. Right? So that is the method of doing 24th problem. I hope you are observing 25th one also. Find the domain of, copy that 24th one. Fifth problem. The domain of x plus 1 upon root of x square minus 5x plus 6. The domain of root x plus 1 upon root of x square minus 5x plus 6. I hope you have copied that problem. Now, how to do this one? This is in the form of f of x upon g of x. That function is defined if g of x is not equals to 0, right? Means this function is defined if x square minus 5x plus 6 are, that means this root is not equals to 0. Wherever there is root, that means you just substitute x square minus 5x plus 6 is not equals to 0. And you know very well that this should be greater than 0. Right? That means every root, every under root should be greater than 0. Am I right? You can do this problem by using a small correction like the denominator should be always greater than 0. Right? Why? Because it should not be equals to 0. Why? If it is equals to 0, this is not defined. So it should be greater than 0. You can write this one as x minus 2 into x minus 3 greater than 0. This is in the form of x minus alpha into x minus beta greater than 0. Means x should not lie between alpha and beta. You can represent that one as x belongs to minus infinite comma alpha union beta comma infinite, where alpha is the least value, beta is highest value. Means x belongs to minus infinite comma 2 union 3 comma infinity. Copy this one. Already I have given these four relations, these four synapses at the time of introduction of domain and range concept. Find the domain of f of x is equal to log of 18x minus x square minus 77. Now, this is in which form? At the time of introduction, I said this is in which form? The problem is in the form of log f of x, means log f of x means f of x is greater than 0. Understood? That means 18 x minus x square minus 77 is greater than 0. The coefficient of x square is negative, so it becomes somewhat heavy to find out the roots of this equation. Hence, I request you to multiply throughout in equation with a negative number. So you are going to get x square minus 18x plus 77 is less than 0. If any inequation has been multiplied with a negative number, the sign will be changed. Obviously, x belongs to 7, 11. 11 sevens are 77, right? 11 plus 7 is equals to 18. So the answer should be like this. That means you can write this one as x minus 7 into x minus 11 is less than 0. X belongs to alpha comma beta in open interval, means 7 comma 11, where alpha is equal to 7, beta is equal to 11. Copy this one. Now the next problem, the domain of log 5 to the base. Find the domain of log 5 to the base x. Log 5 to the base x. Yes. See, you can write, let us consider this is f of x. Let us consider that is f of x. F of x is equals to log 5 to the base x. We are having one fundamental like log a base b can be written as log a upon log b. Right? Similarly, log 5 base x can be written as log 5 upon log x. Right? This is defined. Right? If log x value is not equals to 0, right? Log x value is not equals to 0, then it is defined. Log x value is not equal to 0 means x value should not be equals to, right? Log, that means x value should not be equals to 1. Why? Because log 1 is equals to 0, right? So r minus 1. All positive real numbers minus 1. Copy this one. I am repeating that problem again. The given problem is in the form of log a base b. Log a base b can be written as log a by log b. Okay. So log 5 by log x. This is defined if log x value is not equals to 0. Log x value is not equal to 0 means x value should not be equals to 1. So r plus, sir, why you took only r plus but not r? Logarithm is defined for only positive real numbers. Logarithm will not be defined for negative numbers. So it is r plus minus this one. Okay, all real numbers except 1. Copy this one. Now see that problem number. I am going to share that problem number. Next problem. Yeah, see that problem number 28. Yes. See that problem number 28, which is on the screen. F of x is equals to mod of x by 2. F of x is equal to modulus of x by 2, right? Given to you. And he has given f is a function from real number to the codomain set B. Then what will be that is it is surjection. Okay, E is a surjection. Then B is equals to. Okay, now I am repeating. Given f of x is equals to modulus of x by 2, right? F of f is a function from real number set to B, right? I want to find out is a surjection. Then what is called B? First of all, let me recall what is called a surjective function. The function whose codomain is equals to range is said to be surjective function, right? So if you find out the range of this one, then it is over. That means what is codomain? Codomain is equals to B. Codomain is equals to capital B, which is equals to range. Codomain is equals to range. Then it is said to be surjective function. Then what is the range of this one? Whatever you substitute, the domain is R. The domain is capital R, right? What will be the range? Observe. Suppose if I substitute this, if I substitute x is equals to 0, I am going to get 0 by 2 under mod. It is 0, right? Okay. If I substitute x is equal to 0, I am going to get 0 by 2. It is 0. If I substitute any negative number, minus 1, if I substitute, minus under mod minus 1 by 2, it is 1 by 2. It is positive real number. So whatever you substitute, you are going to get any positive real number only. Why? Because here you are having modulus, right? So whatever may be the R value, it is whatever may be the domain, even it is negative or positive, you are going to get only positive real numbers. Or means union 0, right? I am repeating this problem again. F of x is equals to modulus of x by 2 given to you, right? And he asked you f is a function from real number to capital B, set B, where is a surjective function. It is a surjective function. Then he asked you to find out the set B. That means what is the inner meaning of it? What is the inner meaning of it? Given function is surjective, means codomain is equals to range. The codomain is the entire set B is said to be codomain. That is nothing but range. Why? Because it is surjective. So what will be B value? It is nothing but range. See how what is called range, sir? Whatever you substitute the input, the answer whatever you got, it is said to be output. Output is said to be range of that function. So if I substitute 0, right? Why? Because it is neutral value between negative to positive. Hence I am going to take 0 initially. So it is 0 by 2. It is 0. Right? And suppose if I take negative number, whatever may be the negative number, I am going to get positive only. That's why all positive real numbers are 0. Copy this one. I hope you are copying that. Yeah, one student Varun has raised his hand. May I know what is the reason? He can speak. And another student raised her hand, Archana. She can speak. Yeah, okay, right on. The next problem, I am going to share the next problem on the screen. Twenty-ninth one. Observe that problem, what has been given to you. Capital A is equals to X such that X belongs to capital R. Right? X not equals to 0 already given. X not equals to 0. Minus 4 less than or equal to X less than or equal to 4. And F maps A to R is defined by F of X is equals to mod X by X. For X belongs to capital A, then the range of F is equals to. Actually, you should know which type of function has been given to you. See here, the function mod X by X is equals to the function mod X by X is called as a signum function. I am going to repeat. You got this signum function in your first PUC, right? I am repeating that nature of signum function, right? Mod X by X. See here, F of X is equals to mod X by X is called signum function. It consists of three values: minus 1 if X is less than 1, right? And it is 0 if X is equals to 0, and it is equals to 1 if X is greater than 1. That means these three are the elements of range, but that means the graph of signum function will be like this. Even you got in your first PUC, this is 0, this is negative 1, this is positive 1, right? Now, but in the question he has given you directly that X is not equals to 0. Therefore, the range is equals to, given X is not equals to 0. Therefore, required range is equals to minus 1 comma 1. Only two elements, right? I am repeating. Mod X by X is called as a signum function. Signum function graph will be like this. Whatever you substitute, you are going to get either 1 or minus 1 or 0, right? Here in the problem, he has asked you that X value is not equals to 0. Why? Because if I substitute X is equal to 0, it may not define. So here he has given you X is not equals to 0, and he asked you to take some values minus 4 comma 4 in between. Even you can observe minus mod of minus 4. See here, mod of minus 4 by minus 4. That means mod of minus 4 value is 4. 4 upon minus 4 value is equal to minus 1. Right? If I take 4 by 4 value is equals to 1. Okay, like that you are going to. That fellow, that means in the question he asked you that x should not be equals to 0. So I am going to exclude that x is equals to 0 value. That means I am not taking x is equals to 0. Hence, I will have only two values called minus 1 comma 1. Copy this one and that means including the graph. Now, observe the problem what has been given to you. The domain comma range of mod x plus mod of x plus 1. Yes, it is very simple to say. First of all, to find out the domain of this function, just check where you are going to get infinite in this function. I hope you never get infinite value. Suppose whatever the value you substitute in the place of x, whatever the value you substitute in the place of x, you never get infinity. Therefore, the function is defined for all real numbers. See the solution. F of x is defined for all x belongs to R. Therefore, the domain of this function is capital R. Why? Because you never get infinite in that function. Okay, whatever the value substitute. Now, whatever value you substitute, you are going to get the value which is greater than 1. Greater than, that means the range. Range is equals to. That means whatever the value you substitute in the place of x, okay, you are going to get the value above 1 to infinity. That means 1 or above 1, that is greater than or equal to 1. Let me check one value by taking x is equal to 0. If I substitute x is equal to 0 here, I am going to get mod of 0 value is 0 plus mod of 0 plus 1 is equals to 1. That is equals to 1 now. Now, let me take x is equal to 1 by 2. 1 by 2 under mod is 1 by 2 plus 1 by 2 plus 1, it is equals to 3 by 2. 1 by 2 plus 3 by 2 is equals to 4 by 2 is equals to 2. That means that is greater than or equal to 1. So, the range of that function becomes 1 comma infinity. 1 is closed interval. If I substitute 0, I am going to get 1. So, this is the answer. I am repeating. Range is nothing but the output which you got after substitution of domain. Means, now itself I said all real numbers I can substitute. nowhere I am going to get infinite. Means the function is defined for all values of x, real numbers. So domain is equals to capital R. So I am going to substitute any value. Whatever the value you take, the value always lies between. The answer always lies between 1 comma infinity. Even you can check, okay, by taking minus 1 by 2 like this. I am going to check x is equal to minus 1 by 2, right? Mod of minus 1 by 2 plus mod of minus 1 by 2 plus 1, right? Which is equals to, okay, this is 1 by 2 plus 1 minus 1 by 2 is 1 by 2, obviously 1. Understood? So whatever the value you are going to take, that lies between 1 comma infinity. Copy this one. Now see that problem number 31 I am going to share on the screen. Yes, observe that 31st problem which is on the screen. F and H are from capital A into B, where A is equals to A, B, C, D, B is equal to S, T, U, defined as F of A is equal to T, F of B is equal to S, like that he has given you. First of all, write down that one in ordered pace, like F is equals to, observe that problem clearly. F is equals to A comma T, means F of A is equal to T given to you, B comma S, okay, C comma S, okay, D comma U, okay. Now H is equals to A comma S, B comma T, C comma S, A comma U, and D comma U. Now he has given you F and H are functions. First option, that is wrong. See here, just observe, sir, how to check whether it is a function or not. If domain repeats, it is not a function. What is the domain of this F? A, B, C, D. So F is a function. That means the domain of F has not repeated, hence it is a function. Now observe the domain of H. A, B, C, A. A has been repeated, hence it is not a function. That means, how sir, why it is not a function? If it repeats, why it is not a function? What is called a function? Every element in set A should have only one image in capital B. But here, the element small a is having two images. One is S, another one is U. Hence, H is not a function. I repeat, first point, if domain repeats, it is not a function. Why it is not a function if domain repeats? What is the definition of a function? According to function definition, every element in set A should have only one image in B, but A is having two images called S and U. Hence, it is not a function. So, first of all, what is that one? As F is a function. Okay, H is not a function since the element small a is having two images. Okay, yes, comma u. Hence, it is not a function. Copy this one. Yes. In the next class, let me discuss the remaining problems. Okay. Mr. Dhanraj, may I know what is your doubt?
Sir, I did not understand 27th problem, sir.
Yeah, wait a minute. What is the 27th one? Can you repeat, please?
The domain of log 5, sir.
Log 5 basics.
Yes.
Okay. I am going to repeat it again once more. Okay. Now, one student asked me one problem. Log 5 basics. This is in which form? Log 5 by log x. You can write it as. Why? Because log a to the base b, log a to the base b can be written as log a by log b. Okay. So you can write this one as log 5 upon log x. See, the denominator is log x now. Suppose if the denominator is 0, right? If the denominator becomes 0, you won't get, that means you are going to get infinity. Hence, if this function is defined, this is entirely f of x. This function is defined if log x is not equals to 0, log x is not equals to 0. So log x should not be equals to 0 means x should not be equals to 1. Why, sir? Log 1 value is equal to 0. Right? Log 1 value is equal to 0. It should not be equals to 0 means x should not be equals to 1. Am I right? So x should not be equals to 1 means it should be r minus 1. But logarithm will exist for only positive real numbers. So it is r plus minus 1. All positive real numbers except 1 is the answer. Copy this one. I am very happy. After so many days, one student asked me the doubt, and I am very happy literally. Thank you, Mr. Dhanraj.